Okay, hello everyone, this is Professor Lei. Welcome back. So in this video, we will continue to talk about the last section of the chapter 9 course material, which is related to loss sizing techniques within MRP system. All right. So in this last section, okay, we will detailedly talk about 4 different loss sizing techniques within MRP systems. All right, and we will talk about the key differences among those loss sizing techniques, and further we will use one big problem to illustrate those key differences and what are the key principles when we use different loss sizing techniques. All right, now let's start to talk about today's main topic. All right, so as you can see here, the 4 different loss sizing techniques will be lot for lot, EOQ, list total cost, and list unit cost. All right, but even before we start to talk about these 4 different loss sizing techniques, especially within the MRP system, all right, what means by loss size? Okay, basically, as you can see here, especially within the MRP system, the loss size itself represents the part of the quantities issued in the planned order received and the planned order release sections. Okay, so the loss sizing technique in MRP system essentially is basically going back to basically the optimal order quantity type of the problem, okay, within the operations management field. All right, but here, since actually we are more specifically talking about the material resource planning scheduling procedure, that's why here we give the name loss sizing. Okay, but as I said, basically the loss size technique itself essentially will be the order quantity type of the problem. Okay, so here we actually list 4 different techniques. Okay, in order to balance, the inside cost within the loss sizing type of the problem. Okay, that would be the core thing within the loss sizing techniques. Okay, so since this is related to order quantity type of the problem, okay, actually in chapter 3, when we deal with the inventory management, we already talked about some technique related to order quantity type of the problem, right? So you may still remember that when we talk about the fixed order quantity model, we actually already introduced the EOQ model. All right. Here we will also use EOQ model as one specific, candidate of the loss sizing technique within MRP system. Okay. But here we further actually introduce another 3 different type of loss sizing techniques that are very commonly used within the within different industries, within different companies, when they deal with the MRP system type of the problem. Okay, so before we actually start to illustrate the specific problem by using these 4 different loss sizing techniques. Okay, now let's first look at basically the definition of these 4 different loss sizing techniques. Okay, first of all, it's called lot for lot. Okay, lot for lot actually is very straightforward. Okay, so give a quick example. All right, so basically, if you know that your net requirement for production, okay, is, let's say, 1,000 units. Okay, basically, if your demand is 1,000 units, okay, from the market, if you based on the lot for lot loss sizing technique, okay, you will exactly order that amount in order to match your net requirement. Okay, so lot for lot technique basically is the one of the easiest way within the loss sizing technique. All right, so that's why here under the lot for lot technique, you basically set the plan order exactly matching your net requirements. That's the key principle under the lot for lot technique. Okay, here you see, no matter you produce or you order from other factory, right, from your supplier, you basically order exactly that amount, okay, which is needed in the short period. You will not carry any inventory for the future period. Okay, so this will be one type of the, this would be the characteristic for lot for lot techniques. All right, so actually when we talk about the inventory management in chapter 3, we detailedly talk about 2 different type of costs actually will incur during this whole procedure. Okay, those 2 different costs would be holding cost and also carrying cost, or we call it ordering cost, right? So give you a quick example, right? So let's say in this whole period, all right, the total market demand is 1,000 units. Okay, so you may have two ways of planning, to in order to fit for the market demand. All right, so you can actually use one truck, okay, and then order this whole 1,000 units together from the factory to your warehouse. All right, if you do like that, then you basically your ordering cost will be just one cost, right? Will be just one time cost because you just basically use let's say you rent one truck and let the basically the factory put all those inventory in on that truck and they come to your warehouse, right? So your setup cost or your ordering cost is low, okay? But imagine which type of cost will be high if you do like that. The holding cost will be high. Why? Because let's say in this total period, your basically the market demand is 1,000 units. Okay, but it doesn't mean that you can sell all those 1,000 units immediately at one time, right? So basically, you have to hold those inventory in the whole period of time. Okay, although the inventory amount itself is basically decreasing and decreasing when more and more amount is selling to the market. All right, but overall, your inventory holding cost would be large. Okay, so if you let's say if you only order one time, okay, and if you transfer all that amount from the factory to your warehouse, okay, at one time, your holding cost will be huge, but your carrying cost or your order cost will be low. Okay, and you can even imagine on the other side, at other extreme situation. All right, so each time if you only order the amount that only can fit for this short period of your market demand, okay, then you basically get rid of the carrying cost, right? Because let's say you order this, it come to your warehouse and it sell to the customer immediately. So in that extreme, your carrying cost is basically zero, is very low, all right? But each time, since you only basically fit for that short period of market demand, all right? So each time when you order, you have to, let's say, rent a new truck, to basically transit that amount of product from the factory to your warehouse. So your ordering cost will be huge because each time you need to rent a truck, right? So in that extreme case, your holding cost will be low, but your carrying cost will be high. Okay, now get back to lot for lot technique. Okay, this lot sizing technique is basically corresponding to which extreme situation? Basically, this is corresponding to, right? Basically, this is corresponding to the second situation that I'm talking about, right? Basically, your inventory cost, the holding cost itself, right? Basically, is zero, is minimized, right? Because each time you only order the amount that you need. But since each time you need to rent a new truck to transit that new amount from factory back to your warehouse, right? Your setup cost or basically the ordering cost can be high. Okay, so that's why here the characteristic of lot for lot technique is basically minimizing the carry cost. Okay, but on the other hand, what I'm not showing here is that basically the setup cost or the ordering cost for lot for lot technique will be high. Okay, so understand the key point here. Okay, it's no matter I can say that no matter under which type of technique, it's always basically trying to balancing the basic holding cost and the ordering cost. There's always a trade-off between carrying cost and also the basically the ordering cost. Okay, but based on the specific information context, maybe one technique is actually very fit for that information context, but not fit for other contexts. That's why here we have to understand all those four different lot sizing techniques. All right, and then when we deal with the specific MRP system problem, okay, we can try each one of them, or at least we can calculate each one of loss sizing technique and see which one is the best among alternatives. Okay, that's the thing that we want to do. All right, now let's move to the second technique, which is EOQ technique. Okay, I think right now everyone should already know what is the EOQ technique, right? We spend much time talking about EOQ technique when we deal with inventory management within chapter 3. Okay, now here, since loss sizing technique essentially is still dealing with the optimal order quantity type of the problem, that's why here, of course, EOQ is also one good candidate for us to use when we deal with the loss sizing problem under the MRP system. All right. So first of all, EOQ, right? This will be the equation. Okay. What is this equation represent? All right. EOQ equals to square root of 2ds divided by h. Right. 2ds divided by h. What is d? Again, d would be the annual demand. S is what? S would be the ordering cost. Right. The ordering cost. What is h? H is the holding cost, right? H would be the holding cost. Okay, everyone should already be very clear about the EOQ equation, all right, EOQ model equation. But if you directly just look at this equation, you can immediately find out that within this equation, okay, what we are doing here is essentially exactly trying to balance two different type of costs, right? One cost is called ordering cost, another type of cost is related to the holding cost, right? Although here, in this specific model, all right, the way that we're trying to calculate the order quantity amount, optimal order quantity amount, is by using this way, the square root of 2ds divided by h, all right, under the EOQ model, okay? But where they say that actually within chapter 3, when we talk about the fixed order quantity model, right, we say that, okay, if the time period itself is a continuous time period, all right, then we can say, okay, EOQ, the Q that we generate from this equation will be the optimal order quantity for sure, okay? But here, why, okay, instead, since EOQ can already give us the optimal order quantity, why we still need to introduce the other three type of the loss sizing techniques? That's because in the MRP system, all right, the time period itself is not continuous. It's discrete anymore. Okay, it's discrete for within the MRP system. It's not actually continuous anymore. That's why EOQ may not be optimal order quantity. Okay, but it's still a very good way of incorporating two different types of costs, which are basically a holding cost and the ordering cost. That's why we still use EOQ as one candidate when we deal with the loss sizing technique in MRP system. Okay, I try to basically make it very clear. Okay, so EOQ basically it may not give us the optimal order quantity, but it will give us at least a very good candidate among those 4 different type of the loss sizing techniques. All right. Now, the third different loss sizing technique is called least total cost. Okay, as I show here, still this is also a dynamic loss sizing technique. Okay, you have to calculate the order quantity by comparing the carrying cost. Still, you see, comparing the carrying cost and the setup cost for various loss sizes. Okay, and the criteria, okay, under least total cost method is that you always pick up the lot, okay, or pick up the order size in which these are most nearly equal or at least closest, okay, between carry cost and the setup cost. Okay, so essentially, you see, under this technique, you are still incorporating both two different type of costs, right? You are trying to balance or trying to have a trade-off between the two different costs, okay? And although actually under the least total cost, you are using different way of trying to balance these two different type of costs, okay, compared to EOQ or lot for lot. But you are still doing like that way, okay? And the criteria, the more specific criteria under least total cost technique, okay, for you to select the specific order quantity is, okay, you basically pick up the lot size that will give you, the most closest, costs between carrying cost and the setup cost. Okay, you may still a little bit confused about how to basically achieve that goal in the whole MRP procedure. Don't worry about it. We will use one good example to illustrate. Okay, I think after that you will be very much clearer about the essential principle under the least total cost. Okay, now another type of the loss sizing technique. Okay, it's called least unit cost. Okay, least unit cost is kind of close to least total cost, but it still has some difference. Okay, so the least unit cost itself is also a dynamic loss sizing technique. Okay, it will add the ordering and the inventory carrying cost for each trial lot size, and then what it needs to do. Okay, this is basically the step that is actually included within the least unit cost technique, but it's not basically included within the least total cost technique. What is that? So after you basically add the ordering and inventory carrying cost for each trial lot size, you have to divide by the number of units in each lot size. Okay, and then you pick the one that with the lowest unit cost. So basically, this is the characteristic, or this is the principle, how you pick up the lot size within the least unit cost type of the method. All right, so you see that still essentially, you see when we are talking about least unit cost technique, okay, what you are trying to balance is still those two different type of costs, right? Ordering cost and the carrying cost. As I said at the beginning, right? If your ordering cost, basically, if you order, one time at the beginning, and basically order all of the money that you need in the whole procedure, you will incur lowest ordering cost. But on the other hand, you will incur most, inventory holding cost. But just because you cannot sell all of them just in a short period, right? You have to hold them during the procedure. All right. So that would be one extreme case. But on the other extreme case, all right, basically, if you only order the amounts that you need in a short period each time, right? Of course, you can kind of get rid of the holding cost, but your ordering cost for the whole period will be large because each time when you need it, you have to order it from your factory, right? So those are the two extreme situation. But here, as I said, basically the 4 different type of techniques is helping you to balance, the ordering cost and the inventory holding cost by using different techniques, by using different way. Okay, but based on the specific information context, which one should be basically the best fit for that information for that specific problem? All right, it still depends on let's say the specific cost number, the specific information context. Okay, so that's why here, before actually we even talk about the specific problem, you need to at least understand, okay, the key point under these 4 different specific type of the lot sizing techniques. Okay, lot for lot is basically exact ordering amount, right? EOQ, basically, this is what we already talked about within chapter 3, right? We detailedly talk about this equation. If you're still a little bit confused about EOQ model, go back to my chapter 3 instructional video. All right, I detailedly talk about EOQ model, both descriptively and also by using a comprehensive, example. Okay, that will be very helpful. Also, here we further introduce the least total cost, right, by having characteristic, the specific characteristic and least unit cost, okay, which is similar to least total cost, but it's different, okay, which is corresponding to another specific characteristic, okay. Now, here, once you get the basic and fundamental sense about what are basically these 4 different techniques and what are the characteristics of these 4 different techniques, now let's move to a specific big example, and I will illustrate, this example by using 4 different techniques. Okay, and given the information context here, all right, basically what we are trying to do is, okay, let's use all these 4 candidates, all these 4 different lot sizing techniques in order to build up our MRP system. Okay, and then finally the conclusion or the thing that we want to figure out is that which lot sizing technique basically will give us the best, result. Okay, what is the best result? Basically the lowest cost. okay, among all of the alternatives, okay, based on within this information context, okay. But I can say that if actually we change, let's say even one single number, okay, showing this whole information context, actually the result may be different, okay. So the key point is not actually about recalculation, it's about how to basically get the sense of average lot sizing technique, okay, such that if I change any number, you can still follow that fashion to get the corresponding result and compare among 4 different techniques. Okay, now let's start to first look at the information context itself. All right. So actually, this problem is also from the textbook. Okay, this problem is a long problem. Actually, it includes a few pages to illustrate it. All right, but here I will try best to illustrate detailedly. But if you are still a little bit confused about something within the procedure, you can go back to the textbook and look at this whole the big problem. All right. Now this problem is considering the MRP lot sizing problem. All right, and the net requirements are already shown for 8 scheduling weeks. Okay. And you see the cost per item is $10. Basically, this is production cost per unit, right? The order cost is $47. All right, basically, let's say if you can view it as renting one truck. Okay, let's say if you rent one truck, you need $47. All right, so ordering cost each time would be $47. Okay, the inventory carrying cost per unit, per week, is 0.5% of the basically the production value, okay? Basically the inventory value, all right? So these are 3 things that we have, all right? And based on these 3 type of the cost of the information, okay? And further, we give the net requirements, okay? The net requirements. You can view it as basically the no matter the production requirement from the customer or from the demand side, right? Basically, this represents the weekly net requirement from week 1 until week 8. Okay. Okay. Now, the simple thing basically, the question itself is very straightforward. Okay, we're trying to use these 4 different ways and try to see which one will actually give us the lowest cost in total. Okay. Now, let's start from lot for lot technique. Lot for lot technique is actually the most straightforward way. Okay, it's easiest for you to calculate, but it may not be the most efficient way. All right. So first of all, if you just look at this big table, all right, at this upper table, okay, the front table. So you see that basically from week 1 to week 8, the net requirement would be 50, 60, 70, 60, 95, 75, 60, and 55, right? Basically, it's exactly what the number showing here. Okay, so that would be very simple. Since under lot for lot, remember what I just said at the beginning. On a lot for lot, you only order the amount that you need in that specific period. Okay, so let's say in week 1, what do you need basically is 50. Then you will order how much? Under lot for lot technique, you only order 50. That's it. All right. So basically, this is corresponding to the exact production technique. Okay, the exact production or exact order technique. Okay, so that's why here, if you need 50 from the demand, all right, you only order this amount, exactly this amount. Okay, then of course, what is your inventory? 0. Why? Because let's say you order it from your factory, you get this 50, and immediately you sell to the customer. Then how many you left within your factory? 0, right? Because you already sell all of them to the customer. That's actually very intuitive. Okay, and then what is the holding cost? Since you don't actually have any inventory in that short period, the holding cost has to be 0. Okay, actually that would be very intuitive. But what is the setup cost or what is ordering cost? As I said, each time when you order, you basically incur $47. Okay, you can view it as, okay, each time when I order, no matter how much amount, I need to rent a truck. That's why I have to incur that amount, right? So each time, you see, no matter you order 50, 60, 70, 60, 95, among all these different periods, you always incur an ordering cost, which is $47 in every period. Okay, in every period, because actually you order for every period. Okay, you order for every period. That's why here, you see, the setup cost in every period is always the same amount, $47. Okay, so if you calculate total cost, it's actually very simple, right? Before you basically calculating the total cost, you have to add up the holding cost, right? In week 1, it's 0. In week 2, it's still 0, right? Because lot for lot sizing technique basically indicates that you won't actually hold any cost during the procedure. Your any inventory is always 0, right? So holding cost is always 0 during this whole 8 different weeks. That's why here, when you calculate total cost, let's say you're at week 1. Your holding cost is 0, your setup cost is $47, then your total cost will be $47. That's it, right? And in the second week, still you don't have any inventory. The holding cost is still 0. You still incur $47 in order to order the 60 new amount, right? And then what is total cost? You use this 47, add up this 47, okay? Because you incur 47 in week 1, you incur another 47 in week 2, then your total cost for 2 periods, okay, for 2 weeks will be 94. So this column basically will be a cumulative amount, okay? Keep that in mind. This will be a cumulative amount, okay? So for example, 376 is not basically corresponding to the cost that only occurred within week 8. No, this is corresponding to the cost in total for week 1 until week 8, okay, for the whole period. So 282 basically is representing the whole cost, the total cost that will incur from week 1 to week 6, okay? So this is a cumulative column. Keep that in mind, all right? So lot for lot technique is actually very easy for you to calculate, right? Basically, each time when you order that amount, since you only ordered the amount that is exactly the same as the requirement, so that's why you don't actually have any holding costs, and each time when you order, you basically incur this $47. That's why basically the total is like this. Okay, so even without this table, you can already very easily get this number. How did you get this number? Think about this. Since each time, or let's say in each week, you incur $47. All right. How many weeks in total? You have 8 weeks, right? You just use 8 times 47. That'll be this amount, 376. Okay. That's actually corresponding to the characteristic of the lot for lot technique. Now, let's move to the EOQ model. Okay. What is EOQ model? Remember, EOQ model basically very easily. EOQ equals to square root of 2D times S divided by H. All right. So this would be the equation that we already talked about within chapter 3. Now, so first of all, within the EOQ model, okay, the first thing that you need to clarify is still the Q amount, okay, the EOQ amount. So based on basically the specific context that we already provide here, okay, what is the EOQ amount? What is the best EOQ amount? Okay, I think right now, since we already learn about how to calculate EOQ, it should not be that hard for you to calculate. Okay, here in order to give you some sense, in order to help you recap the whole procedure within EOQ model, all right, I will lead you guys to guess the amount. You can see that each time when they order, this will be the result, 351. Okay, but how to get this 351 as the EOQ amount? Okay, here I already list the specific procedure. Okay, this whole procedure is also listed within the textbook. Okay, so you can also look at the textbook and find the corresponding information. Okay, as I said, okay, let's do it step by step. All right, so EOQ equals to square root of 2ds over h. What is d? D represents the annual demand. Okay, the average annual demand. Okay, how to get the annual average demand? Okay, so first of all, the demand for this 8 different weeks, you already have this data, right? Okay, now, since you have this 8 different weeks data, can you calculate the average amount for this week, 8 weeks? Of course you can, right? You just add them up and divide by 8. That will be the average amount for this 8 weeks, okay? And normally, in a year, okay, how many weeks we have normally? 52 weeks, right? 52 weeks. That's why here, if you want to calculate the annual demand based on the information related to this 8 weeks, all right, what is the annual demand? You add up all this number shown here, okay, divide by 8. That'll be the average, what? The average weekly demand, right? The average weekly demand is basically this amount, all this add up and divide by 8. And then you times 552, that will give you the annual demand, which is 3,412.5 units. That's it. Okay, so this will be the annual demand based on 8 weeks information. Okay, and now after you get annual demand, you already get D. Okay, but you still need to get the other number in order to get the EOQ. Okay, so what is S? What is H? First of all, if you look at this, the cost per item is $10. The inventory carrying cost per week is 0.5%. Okay, is 0.5%. Okay, so how to calculate annual holding cost? Okay, so 0.5% is per week. If we calculate annual holding cost, okay, you times 52 weeks, right? That will be basically your inventory carrying cost, right? The inventory carrying cost. Okay, and then since this is based on the production cost of every unit, which is $10, okay? So when you calculate the holding cost, or we call the carrying cost, you use this $10 times 0.5%. That's for 1 week. But since what we need, okay, within this equation, it's not for 1 week, it's for annual, right? It's for annual because you see D is the annual demand. H should be correspond to that. H is also annual inventory holding cost, right? Annual inventory holding cost. So in order to get that amount, you have to use 10 times 0.5% and then times 52 weeks because you are corresponding to annual, all right? You are corresponding to annual. So that's why here, okay, as I list here, you use 0.5% times 10, that will give you basically the holding cost per week, and then you times 52 weeks, that will give you basically the annual holding cost. That would be H. Okay, and still we have another thing, which is the ordering cost or setup cost, which is 47. Okay, so basically per order, you actually will incur $47. Very easy, all right? So right now, you already get the D, S, and H, as I show here. Okay, as I show here. Okay, so in order to get the EOQ, very easy. You just plug all the number into that specific equation, the square root of 2ds over h. If after you plug in all the number, you will get this amount, which is 351 units. That's why here you see each time when you order 351 units. Okay, so here I already give you and describe the whole procedure of how we basically calculate the specific EOQ amount. Okay, now after you get the 351, let's start to deal with this table. Okay, first of all, still from week 1, week 8, the net requirement is still there. This is basically the information that you already get. All right, and then since each time you order 351 units. That's why here in week 1, this will be 351 units. Okay, now since in week 1, the amount that actually is needed from the customer demand is 50. All right, but you order 351. Can you basically sell all of them? No, of course not, right? You can only sell 50 units out of the 351 units. Okay, so then what is the end inventory? How to get this amount? Very easy, right? Use 351 minus 50. That will give you the ending inventory, which is 301. That's it. Very easy. All right. Now, after you get to the end inventory, which is 301, how can we get to the holding cost? Okay, this is actually very easy, right? 301 is basically inventory, and then inventory carrying cost for that week is 0.5%. That's why here you times basically 0.5%. That will give you a holding cost. Okay, you can calculate yourself. Okay, and you will actually you will see this amount. All right, so for that week, the holding cost is this amount. Okay, and in that week, since you ordered this 351 units, okay, let's say from your factory, you of course will incur setup cost, which is $47. Okay, and if you calculate total cost, so basically holding cost plus setup cost, you will get to 62.05. That's it. Very easy. All right, now let's move to week 2. Your week 2, you need 60. Okay, you need basically 60 to fit for the market demand. Do you basically need to order new amount? No. Why? You still have any inventory, right? At the end of week 1, your end inventory is 301, right? 301 is still is already at your warehouse, right? And your new requirement is 60. They basically just use the 60 within your inventory and in order to fit for the customer demand, right? So here in week 2, you don't actually need to order some new amount, okay? And after you fit for your market demand by the 60 units, what is this new ending inventory? How to get this amount? Very easy, right? 301 minus 60, you get 241, okay? 301 minus 60, you get 241. That's it. That's your new ending inventory, okay? So what is the holding cost? Because at the end of a week 2, all right, you have to hold this new ending inventory showing here, right? You see, this amount is iteratively changing. It's actually becoming smaller and smaller. But as long as there is inventory in your warehouse, you have to hold it. And as long as you hold it, you have to basically incur the corresponding holding cost. Okay, that's actually very intuitive. Still, how to get to this number? You use 241 times the corresponding, you see, the basically 0.5%, all right, of your, 0.5%, and also times 10, okay? Yeah, also times 10 because the 10 is production cost. It's 0.5% of the production cost. So 10 times 0.5% and then times the 241. That's what gave you 12.05. Okay, that will be the holding cost. All right, very easy. But here you see, you don't actually need to incur setup cost because in this week, you don't actually need to order new amount. That's why the setup cost is still zero. It's zero. Okay, so in week 1, the total cost is 62.05. And in week 2, the total cost basically, okay, the new total cost is 12.05. Okay, then cumulatively 62.05 plus this 12.05 plus this 0 is 74.1. Okay, still remember this column is cumulative. Okay, so the total cost will be 74.1. Okay, by following this fashion, it can be also used for week 3 because week 3 you need 70, but you still have 241 in your warehouse. You don't actually need to produce or order new items. All right, you just use this inventory, and at the end of week 3, you end up with 171 units, right? Okay, you still use this amount times 10 times 0.5% to get this holding cost. Since you don't actually produce or order new amounts, your setup cost is still 0. Okay, and when you calculate the total cost, you use this amount plus 8.55 plus 0. That will be the final result. Okay, so you keep this fashion for week 4, week 5 because you still have some enough end inventory. But at the end of week 5, you see your end inventory is become 16. Okay, it's already become 16. So if we go to week 6, what is the requirement for week 6? It's 75. You only have 16, but you need 75. Can you basically fit for that market amount? No, you cannot. Okay, no, you cannot. Then at that time, what do you need to do? You have to order some new amount, right? And based on EOQ model, each time when you order how much? 351. That's why here in week 6, you will order some new 351 units. All right. So basically, you have 16 in your warehouse. This will be the new, basically the new total amount that you add up from, based on the 16, and you need to basically sell the 75 units. So you use this amount plus the new amount minus 75 will be the amount that actually will stay within your warehouse at the end of this week. Okay, that's actually very intuitive. And here, still use this amount times 10 times 0.5%. That will give you the holding cost. All right, and since in this amount, right, you order some new amount. That's why you incur a setup cost. You see, during this period, you don't actually incur setup cost. But each time if you order new amount, no matter what that amount is, as long as you order some new amount, you will incur 47. All right, and then you iteratively calculate to the cost until the end. Okay, until the end. So if you look at these two different techniques, okay, but before we start to introduce the list total cost and list unit cost, which method under this information context should we pick? It's very clear, right? You just compare which two numbers. In this the law for lot technique, okay, the total cost would be 376. Okay, but for EOQ, what is the total cost? It's 171.05. So this amount is basically much lower than this amount. That's why here we should pick up EOQ if we only consider these two methods. Okay, EOQ is better. Now let's move to the next two specific techniques and see whether EOQ is the best among all the four, or we can have some other better way. Okay, now the least total cost. Okay, the least total cost actually is a very interesting technique. Okay, actually, if you look, so basically, this will be the corresponding table shown here. Okay, but before we can get this table, we also need to do some calculation, which is also already shown within this upper front, table. Okay, so I will tell you how to basically calculate every specific amount within this table. Okay, actually, you may feel this is a little bit complicated, but actually the calculation procedure is very straightforward as long as you already understand the key point shown here. Okay, now what this means, especially within this, this blue area. Okay, so in the EOQ model, okay, basically each time when we order the amount, we exactly order some amount that is basically is optimal under EOQ equation, right? That would be what we want to do. But for the least total cost, that's not what we are gonna order, okay? But we have to choose the best lot size among alternatives, okay? So since you already know, okay, these two columns, all right, these are the information that we already so provided from the information context, right? From week 1 to week 8, these are the net requirements, okay? So under the least total cost, the first question you need to ask, okay, is that in the week 1, should I order, the amount only for this week, or for the next 2 weeks, or for next 3 weeks, next 4 weeks, or next 5 weeks, or next 6 weeks, next 7 weeks, or total 8 weeks? Okay, that would be the first question we actually need to ask ourselves. Okay, and then we have to calculate based on certain criteria. Okay, we will detail talk about this column. Okay, but here we will basically the first decision that we need to kind of make is that should I order the amount that is required, that it can fit for the first week or first 2 weeks or first 3 weeks, or until first 8 weeks. All right, should I order that amount, and which specific candidate is the best among all of the alternatives? Okay, then how to decide that is based on the criteria. Okay, actually I just show it here. Okay, we are basically trying to use the lot size that can provide us, okay, the most closest total carrying cost and the setup cost. Okay, what that means. Remember, we have the carrying cost, we have setup cost. Okay, by choosing a different lot size, okay, your total carrying cost and your total setup cost correspond, these two different costs will be different. We're trying to basically pick up the lot size that will give us the closest, two different costs, carrying cost and setup cost. How to do that? Very simple. Let's do it. Now, suppose you only order for week 1, how much you should order? If you look at this table, how much you should order? You should only order 50, right? Okay, now, if at the beginning of week 1, if you want to order for the first 2 weeks, how many you should order? You should order 50 plus 60, which is 130. Oh, sorry, 110, right? 110, which is exactly showing here, 110. At the beginning of week 1, if you order for the next 3 weeks, how many should order? 50 plus 60 plus 70, which is 180, which is exactly showing here, right? This is how basically this column of numbers comes out. Okay, how this number comes out. Basically, all this means is that, okay, at the beginning of week 1, how many should I order? Should I basically order for the amount that can already fit for the only this week, or the following 2 weeks, following 3 weeks, until following 8 weeks? Okay, so based on different decision, of course, the order amount will be increasing, will be different, right? So you see 525, you can even imagine how to get this 525. Since actually at the beginning of week 1, you order all of the amounts that is required for this 8 weeks. How many you should order? You basically add up all of them, right? Add up all of them. You can see this will be 525. Okay, now, basically these are all different alternatives or all different options that you can choose. But among all those options, only one option is the best based on the criteria of least total cost. Okay, what is the criteria of least total cost? Again, you want to pick up the option that will give you the most closest total carrying cost and total ordering cost. Okay, now let's look at this. So if you basically only if you only order for week 1, your order quantity is 50. Okay, what is inventory left? 0. Why? Because you only order for week 1, right? Then basically, after you order, you immediately sell all of them, all right? So there's no inventory in your warehouse. That's why the carrying cost is 0. What is the order cost? 47. Okay, 47. And then what is total cost? 47. Okay, now, again, repeat this. If you're saying, okay, that's not good, okay, let's say if we choose the option of week 1 through 2, basically it means that, okay, at the beginning of week 1, let's order the amount, okay, that's required for the first 2 weeks. What is the amount? 110, all right, 110. Okay, now, this is the carrying cost, which is $3. How we get this $3? Okay, very easy. Think about this flow. At the beginning of week 1, you order 110. Okay? At the end of week 1, how much inventory is still within your warehouse? At the beginning of week 1, okay, you order the amount for basically for the future 2 weeks. During the week 1, you sell 50. How many is still in the warehouse? You still have 60, right? Because that 60 is for basically is already prepared for the second week. Okay? So 60 is basically the inventory is still within your warehouse. Okay? So 60 times what? Times 10 times 0.5% is the corresponding carrying cost, which is 3. Okay? Let me repeat this again. If you choose this option, basically means that at the beginning of week 1, you try to basically order the amount for the future 2 weeks. All right, that's why you order 110. During week 1, you already sell 50. Then you still have 60 in your warehouse, right? That 60 is basically prepared for the second week. Since you keep this 60, you have to incur carrying cost. How to basically calculate this? Simple enough, right? 60 times 10 times 0.5%. That actually will give you $3. Okay? And since you ordered that at the beginning of week 1, yeah, you also basically incur this $47 as the ordering cost, right? So if you compare these two rows, the difference between these two amounts is 47. The difference between these two amounts here is 44, right? Because 47 minus 3 is 44. Okay? We are trying to basically pick up the one or pick up the row that will give us the lowest difference. The lowest difference. So if you only have these two rows, which one you should pick? You should pick up the second row because their difference is 44. This difference is 47. Of course, the second option is better. Okay? But it may not be the best among all the different options. Let's look at 1 through 3. Okay, now, at the beginning of week 1, if you decide to order for the next 3 weeks, how many you should order? I already talked about this, right? 50 plus 60 plus 70, which is 180. Okay, I also list here. Okay, just as a supplemental material. Okay, this will be the 180. Okay, now suppose at the end of week 1, how many inventory is still within your warehouse? You have 180 at the beginning of week 1. At the end of week 1, you still have 180 minus 50, right? Because you already sell this 50 at week 1. You still have 130 in your warehouse. Use 130 times this 10 times 0.5%. That will give you basically the inventory holding cost that you would incur basically during week 1, right? Or at the end of week 1, more specifically, right? But, okay, then in week 2, your beginning inventory will be exactly this amount, which is 130, okay? And during the week 2, you also sell another, how many amount? 60, right? Which is showing here, okay? So at the end of week 2, how many inventory is still in your warehouse? You still have 70, right? Why? 130 minus 60 will be 70, right? This 70 is exactly the amount that you prepare for week 3, right? Since you still also need to keep this 70 for week 3, that's why here you also need to incur an inventory cost for this 70 amount, which is 70 times 10 times 0.5%, which is, if you add all the amount, it will be $10. That's why here this carrying cost is $10. Okay, I already showed you the detailed math procedure with the description. Okay, for this $10. All right. Again, at the end of week 1, you need to keep this 130. That's why this is the corresponding holding cost. At the end of week 2, you also need to incur. Basically, you need to keep this 70 amount. That's why you need to incur the corresponding inventory cost. That's why in total it will be $10. That's basically the thing showing here. Okay, you still only just order one time, right? Because you basically just order at the beginning of week 1, right? And then you do not do anything related to ordering. That's why you see, this will be the carrying cost, there will be the ordering cost. And if you look at the difference, what is the difference? 47 minus 10 would be 37. So the difference is becoming even smaller compared to the first 2 rows. Okay, now if you basically continually, do it this way, all right, for 1 through 4, 1 through 5, 1 through 6, 1 through 7, 1 through 8, you will get the corresponding numbers, okay, showing all within this column, okay? So here, if you look at what I show here, right? If you look at 1 through 5, okay? So the order amount is very easy to get, right? 1 through 5 would be 50 plus 60 plus 70 plus 60 plus 95, which is exactly what I show here. The order amount is 335, okay? But how to get a $38 for carrying cost? Simple, right? Because let's say you already ordered the 335 at the beginning of week 1, okay? And during week 1, you basically already sell this 50 amount. Then for the other amount, you have to incur the carrying cost, okay? That's why 335 minus 50 times 10 times 0.5%. That's basically your carrying cost in the first week, okay? In the first week, or at the end of the first week. And this is corresponding to the carrying cost at the end of the second week. This is basically carrying cost corresponding to basically at the end of third week. And this would be the carrying cost at the end of the fourth week, okay? And since at week 5, you already sell all of them, then that's why here, basically the carrying cost at week 5 is 0. That's why I didn't list here. And total amount for the carrying cost is $38. That's why here it's $38. Okay, so you can do like this for all this 8 different actually 9 different rows, all right, and it will show you the different carrying cost. And you can see that ordering cost itself is always 47 because you only order one time. Okay, you only order one time, all right. And if you compare these 2 different columns, you will see that especially these 2 different, okay, these 2 different number, their difference itself is the smallest. Okay, these 2 difference yeah, sales is the smallest. That's why you see 47 minus 38 basically is 9. This is basically the smallest. That's why 1 through 5 is the best among all of the alternatives by using least total cost techniques. Okay, so that's why here you see since 1 through 5 is the best. Okay, what we are doing is not just for 1 through 5, right? We're still basically doing for week 6, week 7, and week 8, right? 1 to 8 is the final planning. Since 1 through 5 is best, okay, starting from 1 to another specific week, okay, and then 6 until 8 is still, basically need to schedule a plan, right? We repeat that technique, the least total cost technique, for basically 6, starting from week 6 until week 8, okay? And here you see, at the beginning of week 6, you actually have another 3 options, right? Week 6 to week 7, week 6 to week 8, okay? That's why in these three options, you have to also, like this blue part, right? Here you have 3 options. Among these 3 options, you have to basically pick up the best option, okay? Following the same method, exactly the same method that we just mentioned. And here I will not repeat again, but here, in order to help you actually here, list how we basically get, let's say, for this specific amount, $3 for week 6 to week 7 option, okay? You can try to basically get all the numbers showing here yourself. That will actually be very helpful for you to get a deeper understanding about this specific technique, okay? And once you get all of them, again, what two numbers we should compete or we should compare, all right? These 2 numbers, right? And you see that, of course, the difference between 8.5 and 47 is the smallest, right? That's why here, okay, basically tells us, all right, first of all, starting from week 1, we should order the amount that is actually can cover week 1 through week 5, okay? And then in week 6, we should basically order amount that can cover week 6, week 7, and week 8. Okay, so basically, how many times you basically order? You only order twice. Okay, the first time you order at the beginning of week 1. The second time you basically at the beginning of week 6. Okay, at the beginning of week 1, you already order all the amount for the first 5 weeks, and at the beginning of week 6, you order all the amounts that actually are required by the last 3 weeks, week 6, week 7, and week 8. Okay, now this comes to our table. Okay, so that's why here you see at week 1, you order 335, right? 335. 50 is required, so you still have this ending inventory. The corresponding holding cost for that week is this amount. The setup cost is 47, and then you add it up to get the total cost. Okay. And then you still use this inventory, right? You don't actually order new amount because it is already enough, right? You minus the 60, then the end inventory is this amount, and for this end inventory, you still need to hold it. That's why this is the corresponding holding cost. But in this week, you don't actually need to order new amount. That's why setup cost is 0. That's why you see cumulatively is 72.5. Okay, you repeat this until end of week 5. Okay, and you should not have any inventory anymore because at the beginning when you order, you plan to basically feed for the first 5 weeks. So at the end of week 5, you don't actually have any inventory. Okay, that's actually very intuitive. That's why holding cost is 0, and the setup cost is 0, and the total cost is 85. You see, 85 is corresponding to this amount. Okay, and basically if you add up all this amount here, this should correspond to what? It should correspond to this $38. Okay, and then, okay, you don't actually have any inventory anymore, right? And at the beginning of week 6, you order another new amount, right? Which is covering the last 3 weeks, which is 190. Okay, 190, right? You see, 190. That's why here, okay, you order new 190, and then the requirement is 75 for this specific week 6, then the annual inventory is basically the the difference between two, right? And then you calculate the corresponding holding cost. And since in this week, you order this new 190, you will incur the setup cost. And that's why the total cost is showing here. And you iteratively do this until finally you get the total cost for the whole week 8, which is 140.05. So based on this total cost, okay, under this specific information context, your total cost would be 140.05. Okay? Oh, actually, this is 140.50. This is actually a typo within textbook. Okay? So here, if you compare the first 3 different techniques under this specific problem, which one should you pick? You should pick least total cost, because least total cost technique actually will incur $140.50 which is smaller compared to 171.05 or $376. All right. So that's why here least total cost is best among the first 3 alternatives. Now, as I said at the beginning, actually the least unit cost is a little bit similar as the least total cost. Okay. And that's why you can see that, okay, under least unit cost, if you look at this blue part and this, this yellow part, all right, the structure itself is kind of similar, okay? But the key principle, okay, or the key characteristic for us to basically to pick up the best option by using this unit cost is different. It's different. Let me lead you guys to basically look at the whole pattern, look at the whole picture, all right? Still, okay, at the beginning of week 1, you have basically 9 different options, right? You can only order for week 1, or you order at the beginning of week 1, you order an amount that is basically required for the first 2 weeks, or first 3 weeks, or first 4 weeks until first 8 weeks, right? So this will be the corresponding quantity ordered. Okay, so this actually is exactly the same as we just mentioned. Okay, still the carrying cost column and also the ordering cost column. Okay, if you look at this, the first 4 columns is exactly the same as we just mentioned under the least total cost. Okay, so I will not repeat the calculation procedure. Okay, under the least unit cost for these 4 different columns. This is exactly the same. That's why here I say the least unit cost is kind of similar as the least total cost. Okay, except the last step. Okay, but for the previous steps, it's exactly the same. You see, the options, right, is 9 different options, the corresponding quantity order, the corresponding total carrying cost, and total corresponding ordering cost is exactly shown here. Okay, in the least total cost, what we just said is that, okay, we compare the difference between these 2 numbers, okay, and try to pick up basically the lowest difference. That would be the best option among all these different options, okay? But here, the criteria already changes. How to get the new criteria? Very simple, actually. You basically add up the carrying cost and ordering cost, okay, to get the total cost. Okay, so 0 plus 47 is 47. 3 plus 47 is 50. That's it. Okay, you get all the total cost. Actually, this column is exactly the same as shown here. 47, 50, 57, 66, 85, right? You see, exactly the same. Okay, but here you can see that we add up a new column, which is called unit cost. You can even imagine what this column means, right? How to calculate the specific, amount within this specific column. Very simple. This is the total cost, right? This is the corresponding quantity order. If you use total cost divided by the quantity order, that will give you unit cost. That's it. Very simple, right? Use the total cost divided by corresponding quantity order. Under that option, you will get the corresponding unit cost. Okay? For example, this 0.2537. How to get this? You use 85 divided by 335. That will give you 0.2537. That's it. Very simple. Now, if you calculate all of them, okay, the least unit cost, okay, technique will basically pick up the one that actually is corresponding to the lowest least unit cost. Okay, the lowest unit cost. Which one? 0.2530. This is the lowest, right? If you look at all of them, this is the lowest, which is corresponding option 1 through 6. What it means? It means that, okay, the best option, if we follow least unit cost technique, will be at the beginning of week 1, I order all the amount that is required for the first 6 weeks. That's the best option. Okay, that's the best option if we follow this least unit cost technique. Okay, now, again, our total planning is for the first 8 weeks. Okay, here, you know that, okay, at the first time when I order, I should order 1 through 6. Okay, but still you have 7 and 8. You have 7 and 8, those 2 weeks, right? That's why here, this is not actually a question mark. This is basically just 7, all right? So you actually, for the remaining 2 weeks, you have 2 options, right? Either you only order for week 7, or you order for week 7 and week 8, right? And then you can calculate corresponding quantity order, right? You see, for week 7 itself is 60, but for week 7 and week 8, it will be 115, right? Because just add it up, you'll get the 115, right? And you can calculate, very easily calculate the corresponding carrying cost and ordering cost showing here. And essentially get the total cost. And use the total cost divided by the corresponding order quantity. That will give you the unit cost. And you see that this amount, 0.4326, is much smaller compared to 0.7833. Okay, that's why here 7 through 8 is the best option among these 2 options. Okay, so that's why showing here, you see at the beginning of week 1, you order how many? 410. Why is 410? Because 1 through 6 is the best option among all of the alternatives. That's why this is 410 showing here, right? And basically, since in the first week, you only require 50, you end inventory this amount, and then you times 10 times the corresponding 0.5, right? 0.5%, you will get the corresponding holding cost. And since you order in this specific week, so you will incur $47. So the total cost will be this amount. Okay, but then if we move to week 2, you do not actually order new amount because you still have inventory, right? You subtract from 60, all right, you get 300, and then you continue to calculate the holding cost. But the setup cost is 0. Why? Because you do not actually order new amount. That's why in this specific week is 0, and then you calculate total cost. Okay, and then you basically keep this fashion until, okay, at the end of the week 6, you don't actually have any inventory, right? And we say that, okay, we at the beginning of week 7, right, you order 115, which already covered the last 2 months, right? That's why this is 115. And you sell 60 during week 7, this will be the remaining one, right, 55. And then you calculate holding costs and corresponding setup costs. That will give you the total cost cumulatively, right? Cumulatively. Basically, you see this number is always going up because you are calculating cumulatively, okay? I keep emphasizing this point, all right? This is not just for 1 week. This is actually for basically all of the weeks, okay, until this specific number, until this specific week, okay? Now, in week 8, finally you get 153.5, okay? So this will be actually the total week for all of the weeks, starting from week 1 to week 8, okay? So in total, this will be 153.5. That's it, all right? Now, if you look at all of these 4 different techniques, right? As I already listed all of these 4 different techniques, the corresponding number, corresponding result, right? 376 is for lawful lot, 171 is for EOQ, 140.50 is for this total cost, 153.5 is for least unit cost technique. Okay, so 4 different techniques actually give you 4 different results. And in this specific information context, we should pick up least total cost technique because the corresponding cost is lowest. Okay, so but again, if I change to some other numbers, okay, based on different type of techniques, the best technique among all of the alternatives will maybe different, right? Maybe different. It's always depend on the specific number that we show within the specific question. Okay, that's why here is the best way for us to understand all of these 4 different techniques. Okay, in certain situations, maybe one technique is the best. In other situations, maybe another technique is the best. Okay, so it's better to understand all of these 4 different techniques. So these are all for chapter 9 course material. Thanks for watching. See you guys soon.